Okay, the recording is recording. So, first things first, what you will need for the exercises is some development environment, so something where you can write your code and compile it and debug it. So for this we will be using Visual Studio Community Edition. It is free and can be downloaded directly from Microsoft. So let's start with downloading it, and do not confuse it with Visual Studio Code. It has the same name, but Visual Studio Code is garbage in comparison. Zack, that's the right one. I'll put the link to the chat so that you can click on it directly. There is only one annoyance with the free community edition. That is that you need to register it with a Microsoft account. You can of course create a free account which you don't need to use, so basically just a throwaway account for that purpose. Or you can use your real account if you have one, or you can Google and look on the internet for ways to reset the 30-day limitation, since it only wants you to create a free account anyways. There is nothing wrong with just working around it. So once you start the installer, you will see a screen like this, and I strongly recommend to go to languages and select English and remove German, because when you program something and do some mistake, and inevitably it will then throw an error while compiling. If the error is in German and you try to Google it, it will be much harder to find solutions. If you have the error in English, then you will get pretty much all the solutions that are out there. So I always use development environment set to English, as this is really helpful when trying to debug some strange issue. For the workloads, we need to select here desktop development in C++, and for good measure here we can select also the Visual Studio 2019 toolchain. We might need it later, so it's good to have it, and the rest of the configuration for our use case should be good enough. I don't think we will do anything more exotic. Also, if you find out later that you are missing a package or something, then you always have the option to rerun the installer and then just add the missing packages. So there is no loss if you don't install it from the get-go. And of course, then we just run the installer, and this will run for it's complaining. It needs about 12 gigabytes storage. I think on this VMware I didn't give it enough storage. Now it should be fine, but this will be deleted later anyways. It's just to show you the installer. I already have it installed on the other VM which we will be using. So when you start Visual Studio, you get this UI, and then in this case we create a new project, and for the first let's select this console application, so it is just text, and then let's call it big integer, big int. And once it's done, it creates for us a nice project. We can take a look on how this looks on disk. So as you see, we have a solution file. This file contains only a little text that points us to the other files. We can open it in a text editor, and we see that here it basically just contains one reference to one project, which is stored here. So when we go here, we see the actual project. And when you are submitting homework, what we need are all the source files. So first let's compile this. You can just run here on local debugger, then it will compile it and run it automatically. As you see, it just wrote some text as said here in the main function. And when we look here again, we see that some directories were created. This directory just contains the created binary file as well as some debug informations, while another one of the same name, one level deeper. Yes? That will take some time, but you can watch what we are doing here. I don't think we need to wait for everyone to finish the installation for now. So it downloads and it runs, and in the meantime I'm explaining you how the UI works. Otherwise we need to wait probably a long time. But if more people want to do it this way, then we can make a break now, and we wait until all of you have installed the Visual Studio. Yes? We can make a break. That's I'm fine with that. That will be good for my broken voice. The thing is, this may take like an hour to download. I mean, depending on your internet connection. 12 gigabytes is not nothing. How is the download progress for the rest of you? Okay, let's then do a 5-minute break. If anyone wants to ask something in the meantime, you're welcome to. Yes? Yes, you can. Mm-hmm. Yes? It should be able to work with UTF-8 and with normal ASCII. So at least Visual Studio can handle both. And it just sometimes complains that it's not consistent. So if some files are in one encoding and the others are in the other, then it offers you to convert them so that all are in the same. But it should be able to build it either way. Okay, how is the installation progressing? Okay. Okay, as we see here, it's also done, so we can just close the installer. I think it should start it automatically. If it doesn't start it automatically, then we just start it manually. Yeah, it's not starting, so let's just start it manually. Okay, so on the first start you get this screen, and you can either sign in, create an account, or just skip for now. So I will select skip, and here you can select how you want it to look. So the style that you see here, which I'm using, is the slide style, but if you prefer any other one, it doesn't matter, you can choose whatever you want. And this drop down here pretty much just defines the initial arrangement of these various side panels that you have here. So I just usually leave it at default, at general, but you can also select any other. It will just move them around, and you can move them later on anyways as you want. So like this can be just moved to this side, for example, so it's not like you are then locked into what you selected, it's just the initial defaults. Okay, so we select start. It will need to think for a short while. Okay, so now we get this screen, so you have seen it already, and you can either clone some repository of the internet, open a project from disk, open a folder, or create a new project. For here, we can also select continue without code, then it just opens the main window. And that's it to the installation. Is the installation done on your end already? So we can continue. Good. So as I was saying, it creates, when you build it, all these additional files here, which are all basically temporary. So when you later will be submitting a homework, there are two things you can do. One is you just go here, delete this folder, and then just zip those two, or you just go into the folder, select everything but the temporary files and zip that, and then the solution file is not included, which is not a problem, as if you are missing the solution file and open the project file, so this VCX project, then it will automatically recreate such a solution file for you. It's important that when submitting homework you don't just zip the SLN as some people did in the past, because the SLN itself is basically worthless. It's just a list of projects. General idea with Visual Studio is that you can have multiple projects, like for example a main executable, then some library, then another library, then a DLL, maybe some helper tool, etc. So basically every project compiles into an own file, and you can have here a huge amount of different projects bundled together. But for what we will be doing, we'll always only work with one single project, so in this case really just the content of the project directory is relevant. And one more thing maybe about this project thing is, so you can configure, if you go on this properties, you can configure project dependencies. So if you would have multiple projects, then you can tell the compiler how they depend on each other, because if you have an executable that needs a library, you obviously need to build this library first, and by setting these dependencies you can ensure that it will be done in the right order. Okay, so that much to this project. So let's remove what we don't need. I would here recommend to rename the file to just main, because we will need the name begin later for another file. Yes? Mm-hmm. Well, Yeah, but GitHub is public. Do you want to make your homework public instantly? That is not a good idea, I would say. Well, you can make it public after the lecture is done, but in the meantime, you don't want to show your solutions to other course participants. I have JetBrains here as well. You can zip the CLion project and we will see how well this works. Also, I see that a new user appeared. So, who just came? Hotel. Yes. Okay. I have amended the attendance list. Very good. Okay. Any more questions, or can we continue? Okay, let's continue. So, we will implement a couple of own classes during this course. Some of the implementation I will do, some of the implementation you will do as homework, and some of the implementation you will do during the lecture in real time. So, the first project that we will create, we already did, BigInt, and it is the idea here is to create a object of our own which can represent integers which are larger than what the hardware can actually handle. So here we have set our platform to x64, so it's modern AMD 64-bit architecture. So the largest integer that it normally can handle is 64-bit. If we are using some vector extensions, then it could handle in principle larger vectors, but if we really want just a normal integer that we can use, then 64-bit is the limit. And there are applications where you would want 128-bit, 256-bit integers, etc. So one of these applications is, for example, in cryptography, where you want the precision of integers, like for example in RSA encryption. And of course you need key length of kilobits, so there is no hardware, no general purpose hardware that would support that, so you either need to have a purpose-built ASIC implementation, which is of course very fast and very efficient, but also very limited to exactly what it's made to, or you need to find some way in software to handle these larger numbers, and this is what we'll do here. So first let's create this object. So we'll use the class wizard to create a new class. Say BigInt. It is customary when creating classes to give them some prefix letter, for example C, like class, but for the file names it's better to not have this prefix, and we do not have a base class, so we create our BigInt. As you see, just created two files with very little content. The CPP file only contains an include of our actual BigInt, and the BigInt itself just contains the class and a preprocessor definition, which ensures that we don't recursively include the file multiple times. So for starters, we of course will need some constructor and a destructor. And as you know, in C++ it is customary to split your implementation into two files. So you have a source file where the bulk of the code exists, the implementation of how everything works, and then you have a header file which mostly contains only the function prototypes and structs and stuff like that. Of course, you can put some implementation with the header as well, but usually it would be good if it's as little as possible. So if you have a function which only takes one line, you can leave it in the header, but if you need a couple lines, then it's better to keep it in the C file. This helps to other people and yourself later on to understand what you did. If you review the header, then you see just the important informations and don't care for the implementation details. So it's easier to read if it's shorter. Okay. And generally when working with objects, it is such that objects which are larger than a standard type that the CPU can handle, when you are copying them, moving them, passing them as arguments, returning them from functions, etc., this will usually require some additional operations, basically a larger memory copy operation or the invocation of a copy constructor or an assignment operator which might have arbitrary complexity inside. So it's not as performant as just working with machine types, but we want to make it performant. So what we'll do is we will use a so-called copy on write mechanism to share a internal object, such that when we are using our cbkind as an argument or as a return value, that then we don't need to copy the entire content of our internal buffer every time, but instead are just assigning one pointer or two. So let's create this internal structure. We'll just call it sbgint, and we will need, of course, now a pointer that points to it. And we initialize it with null. So in modern versions of C++, you can put the initial values directly where you define your your variables. In older C++ versions, you needed to have all this in your constructor, but I find this much more convenient. Okay, so our big int internal structure will of course need to contain a couple of fields. First of all, it will need to contain a size variable. We use the size underscore t type, as this is defined such that on every platform it will be the max int size. So on 64-bit this will be a 64-bit integer, and if we switch to 32-bit then it would be a 32-bit integer, so that we don't waste memory. Call it size, and let's say this will be the size in bytes. And what we now of course need is the actual data block. We have here two possibilities how we can define it. We can well, first of all we need to decide on the type, so let's say let's do it here. Type def, let's go with, for now, long. So x64 okay, so when we select long, we have a reasonably large data set, but we have one which is bigger, so for testing we can compare the results with just using an operation on int64 if we are only using this size. We could also use here short if we want to test if our code works correctly across multiple chunks. Okay. And the ways we can do it is now here either we have just a chunk pointer p data like this, or the other thing we can do is so here in this case we need to allocate first the structure and then the chunk array. In the latter case we only allocate one larger block, and this is more performance, so we will use this approach. Using an array of size 0 will throw a warning. So what we can do is also we could define that there is at least one chunk, so we just go with yes. The class will be representing an integer number like char, short, long, or int64, just that it will not be limited to 8 bytes, but it will be able to represent a number of an arbitrary length. If you can fit a number into memory, this class will be able to represent it and work with it. So you will be able to do mathematical operations on it and stuff like that. Well, for now the public only contains the constructor and destructor. We will add all the operators later on, but for the starters we just need the ability to hold a value inside. In C++, you have something called inheritance, meaning you can define a class or a struct with certain properties, and you can then later define another class which will inherit all the properties from the parent class and add additional own members like functions. Yes. And virtual means that if you have a function in the base class, so in the parent class, and in the parent class you call this function, but if you have derived that class and you have a derived object which is a function of the same name, then even if it's invoked in the parent class, the call will be redirected to the implementation in the class which was derived from it. So this way you can alter the functions and the behavior of a class you are deriving from. If you don't define a function as virtual, then you would have two functions with the same name, one in the parent, one in the child, which of those functions will be used would then depend on just the type of the pointer on which you are acting right now. But if it's virtual, then the pointer type no longer matters. It will always take the latest implementation. Any more questions? Okay, if we don't have any more questions, let's continue. As said, we will go with this approach, as this way we only need to allocate memory once, which adds performance. But there is one more thing we need. That will be a reference counter. So since this object, this cbegint, multiple instances of cbegint may share the same sbegint, so that we know how long this sbegint is needed and whether it can be modified or not. We need to know how many cbegints are referring to it. And for this we will use a variable on which we can act with atomic operations. Atomic operations means that even if the operation contains multiple steps, it will either succeed in one go or it will fail in one go. It cannot be internally interrupted by another thread. And such variables are quite efficient, as these atomic mechanisms are implemented in the CPU directly with specialized instructions. So we don't need to do any context switches and ask the operating system to do some higher level synchronization operations for us. The CPU just does it on its own. There are two ways how we can implement it. We can either use just a volatile int and then use specialized functions from Windows or whatever platform we are using, or if we want to be platform independent, we can use a reference implementation provided in the standard template library. So for this we need to include atomic, and with it we can define our own atomic variable. So std atomic int is enough. Oops. Ref references, and we make it mutable so that we can access it and even modify it if we need from a read-only operation, but that might not be needed. Why is it complaining? This should be defined. It's complaining that it's not defined, but it is defined. Let's quickly build it and see if it still complains. Okay, it doesn't like the zero type. There is a setting somewhere which we can switch somewhere so that it can work with also zero, but let's just set it to 1. That's fine enough. Usually we'll need some data anyways. Okay. So we have our data structure. So for starters, what we'll do is we'll add a new constructor, one which will assign a value so that we can later on simply assign integer values to our big integer. And to simplify it so that we don't need to write implementations for the for and then another for signed and unsigned data types, we'll just use a template. Type name t value. Okay, so first of all we will need to create such a structure. So let's create a helper function. Alloc data size t size and before we implement the content of this, let's just quickly use it. So alloc data size of t, and then data, comma, reference value, and then so allocate data is defined here at the end. The body is here, which we need to fill in, and template allows us to use different data types. So normally when you have a function like alloc data here, it has a specific type as an argument, in this case size t, but it could be an integer, it could be a double, it could be a pointer, it could be a whole huge object, it could be anything. And only a couple of types can be converted into other types. So the integer types can be converted across each other to double as well, but if you would have a pointer or some complex object or something, then you could not just convert them. Also, such conversions may cause loss of data. So if you convert from a long to a char, then you obviously lose 3/4 of the information. So with a template, what it allows you to do is to define a function with a placeholder type, and then each time the compiler sees you are using a given type, it will copy this code and replace t with whatever type you're using right now. So it allows you this way to be very flexible. And in this case, if we call the constructor, for example, with a char as argument, the size t will be just 1, and memcopy as well will only copy 1 byte. If we call big int, however, with a int64 as argument, it will create a copy of the function where size t evaluates to 8, and memcopy copies 8 characters. Any more questions? it's not really a function, it's a keyword, and when you compile the code, this will really be replaced by just a number. So when you do size of, it will always be very efficient. So here we could alternatively write mptr usize, but this would require much more operations, while the compiler here really just replaces it with a number as like 8 or 2 or whatever. Okay, any other questions? Okay, if there are no other questions, then let's continue. So we have a allocate, and obviously other things which we will need will be something to clean up, but let's start with implementing them. Now let's start with adding some more function input. So as I said, we will need something to also clean up the data later on. Let's call it detach, and as I mentioned, what we want to do is we want to implement it such that this structure will be shared. So let's add another function called attach, which will take such a pointer type. Okay. And to make alloc data work, we will need all these functions to play together. And detach we can already use in the destructor, so that we don't forget to clean up the memory after we've used it. Okay, now let's see how we implement the functions internally. Alloc data, obviously we need to create a new object of type sbgint. Size is greater or not, then we'll actually do something, else we don't do anything. And once we are done, we'll attach our pointer, and this will again check whether this is actually null or not. So let's see here. So VTR we will use malloc to create the object, and for this we need the size of the object as well as the size of the additional there's one bug, this must be the last variable, otherwise it will not work. Let's make the rest be the first one. Okay, because the idea is that here we have like an array with one element, but we can allocate a larger block, and then effectively this array will have as many elements as we give it, but for this trick to work, it must be the last member. I should write this as a comment. So we have our size, then we have basically we need to add the size of all the other chunks. So size of chunk, but we need to count the amount of these chunks. So size count is equals size issue this will give us one value, one too little. So if we have like, let's say if the size is 2 and the size of chunk is 4, then this will drop the remainder, that will get 0. So we need some additional mechanism to, if we have an incomplete chunk that would be dropped, to round up to the next bigger size. Yes? We are creating it here right now. Okay, so that ways how this can be done. One is, for example, that to size we add size of chunk t minus 1, which is the most performant option but also not really elegant. The other one is we use the modulo operation. So if modulo is not 0, then we just plus plus, and basically count should never be 0. It can only be 1. Since this cannot be 0, it's at least 1. So if it's at least 1, then this will ensure that the whole count will also be at least 1. Okay, so we have created it here, and now we need to initialize it. So we need to run the constructor so that this constructor gets run properly. And then of course we need to set the size to our size. And for good measure we could also memset everything. Memset. So we clear the data structure, and this takes size in bytes as an argument, and that should be it. We can initialize the rf with 0 for the measure as well. Okay, and then yes. Well, we created it here. Now it's attributed here. Directly when it's created, it's attributed the value 0. Okay. Yes, and I will post a link on the Moodle. Yeah, bye. Okay, so let's continue. We call our attach function, and in the attach function, the first thing, yes? Well, it's a standard function. It just takes a pointer. Here's stdlib_h. Memset just takes a pointer, then it takes a value, and then it's starting in the pointer overrides the memory with value until it reaches size in bytes. Okay, so now attach function. The first thing we need to do is to detach if something was already attached. The next thing to do is to check if our pointer is null, because if it is null, then we just return, and there is nothing for us to do. And now what we can do is we can since we decided to attach it, so we let's say mptr is equals ptr and ptr a ref punct fetch add 1. So we've assigned it to ourselves and incremented the reference counter by 1. And this is already everything that we do in attach. Now we need to take care for detach. So in detach we first obviously check again if our own pointer is null. If it's null, then just return, nothing to do. And now we need to find a way to detect whether we can delete the object or whether the object is shared amongst other objects. And to do this, we can use the fetch subtract. Fetch subtract. So what fetch subtract does is it subtracts 1 from the value and it returns us the original value of the variable before the subtraction. And this operation can, as I already mentioned, not be interrupted by a different thread. So normally if you would have a normal operation like int x of int x ist gleich this, then x minus minus and return x. So in such a situation, another thread that runs the same code can, like two threads could execute this, then x would be in both threads too, then both threads execute this, and then both threads return 2, even though this value ends up then being 0 at the end. Because if you have two or more threads running on a system, every like they execute one instruction, and before the next instruction gets executed, they can already be interrupted by this operating system scheduler, and then another thread does something. So you can get such inconsistencies. If you use, however, an atomic operation like provided here by our std atomic, then it will internally use a special hardware instruction which does both things and cannot be interrupted. So in this case we know that if this returns 1, so it means a ref was 1 before the subtraction, so it means after the subtraction is 0, so it means that we have the last reference, and it is up to us to clean up the data. So first we need to run the destructor of our sbigint. And then we need to free the memory. Okay. And of course, last thing to do is to set our own pointer to null. Okay. That should be good enough. Null is like the old style and null pointer is the new style, so we should try to always use the new style. Like the old null, if you click on it, if you hold down Control and click on it, it brings you just to a definition where it just is 0. And null pointer is defined as actual keyword, but effectively it's also just 0. But it tells the compiler in more detail that this is actually a pointer. So if you use some software to analyze your code and look for bugs, if you're using the new style of programming, then it has more information and will work more efficiently. Okay, so let's try it out. We need to include it. let's initialize it with no x. Okay, so here at the bottom on locals you have the variables, and as you see, my int actually contains two members. One is the pointer we created here, and another one is something else. I will talk about it later. So you see reference is 1, size is 4, and data, well, we see the first entry, so it contains the right values. And we can of course here now also create like a int64. Assign it, and here we now see data contains like a portion, but the reason why it's not complete is simply because we only defined it with one entry. If we copy the address and go there, we see that it contains the whole data block, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, F. And what you also see is that the bytes here are in reverse order, so it's not like what you would expect. You would maybe expect like 0, 1, 2, so sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, but instead they are kind of reversed. The reason is that if you represent an integer like this, it allows you to cast it to smaller types easier. So if you would have this int 64 and you cast it or just memcopy it on a 4-bit variable, it would just maintain the least significant bits. And while of course this is dangerous, because if you actually use more of your value, then you can lose a part of it, and then the shorter variable will contain invalid data if you just use the pickup variable and don't use most of it. So in this case, only copying the least significant bits will give you a working result. So it's let's say a convenience feature that it is encoded this way. There are some this encoding is called little endian, and there is if you would have the bytes in the right order, it would be called big endian, and there are some architectures which encode data this way. But usually, like most modern architectures, x86, ARM, they all just use little endian. On ARM, there is a option that you could set on some implementations to switch to the big endian encoding, but no one does this. So generally, if you have integers nowadays, you can just save them to a file, and on any other architecture you will be able to load them, and they should be fine without any additional interpretation. So here we also see that we had to use two chunks of data. So we see here also size is 8 and the size of a chunk is 4. And since my voice is getting worse and worse, I think we will finish today a bit earlier. I will give you some homework assignment. I will upload this project to Moodle, and there are two functions that you should implement. For every homework assignment you have 2 lectures time, so like the homework assignment is due always on the over next lecture, so that on the next lecture, if you would have some issues with the assignment, you have the opportunity to ask questions, and then you have still a week till the next lecture to actually finish the assignment. And if there is like a week where there is no lecture because of a holiday or so, then of course then you have 3 weeks. Okay. So the first task will be to convert our content to a hexadecimal string representation. So let's include std string. Let's use face string to hex, and let's give it a argument that we can define whether we want it to be uppercase or whether we want it to be lowercase. And from hex, we should just take a string, and convert it. So these two functions. Yes. And that it's passed by reference and not by value. You're welcome. Okay, so first of all, detach. So this is the assignment. Of course here implement a few test cases. So just create a few strings and test whether your code is working well, so that we just need to run main and then see whether it worked or whether it failed. Let's build it quickly. Right, test. Okay. This needs to return something as well. Just an empty string for now. Okay, good. So I will upload this to the Moodle and the recording as well, and we will see each other, I think, next week. So see you then. Bye bye. Yes? Not all of you are here. I think not all of you are registered for both. That's why I said see you next week. But yes, if you are participating in the lecture, then we'll see each other in what is it, 4 hours from now. Then see you later. Yes? Well, you should have done the part 1 that was last semester. But if you know C++, then you don't need that. Then you can just jump right in. Well, try it and then you will see how well it works. Well, there are like three things in total. There is first of all the low-level programming part 1, which was last semester. Then this semester you have the exercises in the morning, which based on what was taught during last semester. And then in the afternoon you have part 2, but part 2 shows you new things and is not directly linked to the exercises. You practice it, you learn it deeper, and so on. Yes. Any more questions? Okay, then see you later.